We'll pick this one up in the middle in the interest of saving time. So again, we have what we call this the general form of an ellipse when everything is on one side and it's set equal to 0. This is called the general form. Okay. Standard form has the squared binomials of the fractions and it's set equal to 1. So I've picked this up in the middle of it. We've taken the x terms and we've put them together here. We've taken the y terms, we've put them together here, and we've moved the 64 over to the other side by subtracting it. So we have a negative 64 on the right. When we complete the square, we can't have a coefficient to do that. So we moved the 4 out here, and we've moved the 9 out here, leaving us with this. Now we're going to take negative 8, we're going to divide it by 2. Negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. Over here, we're going to take the positive 4 on the inside here, what's in front of the non-squared term. So we have 4 divided by 2 is 2. 2 squared is 4. So I'm adding 4 on the inside. But I'm not actually adding 16. I'm not actually adding 16. I'm adding 16 times 4. That's 64. So here's the 64 that I had from before. Okay? And I'm not actually adding 4, I'm adding 36. Okay? So that gets us into a situation where we're in the positive values there on the right. So we have on the left, we have a 4. Now we're going to write our squared binomial for x. The number that goes in here with x was whatever this was divided by 2. That's negative 4. Over here we have the 9 still on the outside. We have a y. And whatever this was divided by 2, which is 2, we have that equal to the sum of the terms on the right is 36. And we divide by 36 to get this equal to 1. We divide when we want to clean this up. We don't want a coefficient in the numerator. That's why, and that's the main reason why we're going to do 36 divided by 4. That's 9. That's the number that goes down here. Okay? We're going to add to that y plus 2 squared over 4 equal to 1. Why do I keep making the point of saying you're dividing this number by this number? There's going to be a problem eventually where we get to a situation, and I'll ruin the ending. We're going to get to a situation where, let's say we have this. 16 and, I don't know, over here a 32. Let's say we did this problem and we got to a point that looked like that. And we needed to divide by 16 to get that equal to 1. So we divide that by 16 and we divide this by 16. Okay? We haven't had this yet. You haven't seen this yet. But in this case, 32 is bigger than 16. So if I were to reduce that by the normal means, I would end up with this, right? The y term over here is fine. There's nothing wrong with that. But on the left side, with x squared, there's no fraction here, right? So what would we say is a squared and b squared, right? There has to be a denominator. You're like, well, I'll make it a 1. You want to make that a 1? Sure, go ahead. But it's still not right because we have this 2 that's up here. So that's why I say don't just reduce this fraction as it currently sits. Do the denominator divided by the numerator and put that underneath. Because if you did that, what would go in the bottom would be 16 over 32, which is 1/2. Now I have a b squared value. This would be b squared. Okay? This would still be a squared. That one's more conventional, what we're used to seeing. Right? That's why when we get to this point, you want to do this number divided by this number to get that denominator underneath.